Calculation of lambda max for alpha beta unsaturated carbonyl compound. We have to find out first basic value. In case of a six-membered ring, or acyclic parent enons, we can say CH2 double bond CH and CHO, or aldehyde group can be written as C double bond OH. This is our functional group, and this is our alpha carbon, this is beta carbon. So this is called alpha beta unsaturated ketone. In case of a cyclic compound, in case of a cyclic six-membered ring ketone or acyclic parent enon, the basic value is 215 nanometers. In case of a five-membered enon, suppose this is our five-membered enon. In case of five-membered enon, this is our functional group. This is alpha carbon, this is beta carbon, this is alpha beta unsaturated carbonyl compound. In case of a five-membered enon, we have value 202 nanometer. In case of a acyclic and dineon, two ketone group, our value became 45 nanometer. For suppose this is one of the example of this is alpha position, alpha beta unsaturated carbonyl compound. The parent value for every kind of alpha beta unsaturated ketone is 215 nanometer, except for these two, 215 nanometer. And we have, suppose we have double bond extending conjugation for this alpha beta unsaturated carbonyl compound. As we know that the parent value is 215 nanometer, and for double bond extending conjugation is 30 nanometer. But this is another bond which extends the double bond, or extending the double bond of this one in homoannular. In case of this double bond in homoannular extending double bond conjugation, this value will become 39 nanometer for this one. And for double bond extending conjugation, we have 30 nanometer, and if this is homoannular, then it is 39 nanometer. Now we have, suppose the most important part is the alkyl group substituent or ring residue to find out this one. Now I am doing double bond, and this one is exocyclic double bond. This is our functional group, ketone group, and this is alpha position, this is alpha carbon, this is beta carbon, and this is gamma carbon, this is delta, and so on. This is delta plus 1 and delta plus 2, and so higher position. Alkyl substituent or ring residue at both the position, we have one ring residue at beta position, and one ring residue at gamma position, and one ring residue at delta position. So this is most important part. Alpha position have 10 nanometer, one ring residue. Beta position will contribute 12 nanometer, and gamma and higher value delta or delta plus 1, it will provide 18 nanometer. Any higher value will provide 18 nanometer. This is one of the important concept of alpha beta carbonyl compound. Now we have certain groups. Suppose we have a bromine at alpha position, then it will provide, or bromine at beta position, it will provide 30 if it is at alpha, this will provide 25. If beta, this will provide 30. Similarly, chlorine, we have different values for different polar groups. Suppose OH hydroxyl group at alpha is 35, beta is 30, and delta is 50. This is the value.